Hey, so we have this interesting exponential problem on the board. We have 6x raised to the 3x power, and then on the right side we have 2 to the 2 to the 2, and we have to solve this for x. And then what I wanted to go over quick was on the right side we have a few exponent properties. We have the first property that just tells us that for an exponent tower we're calculating from the top to the bottom. So you have this parentheses around the exponent, which indicates that you're calculating the top part first. And just a quick example of that, if you had 3 to the 3 to the 3, that's going to be the same as this, which is 3 to the 27th. The wrong way would be to calculate the bottom first and end up with, if you did this, you'd end up with 27 to the third, which is a much smaller number, and this would be wrong. So that's going to be important when we have this exponent tower in our problem. Then the second property is number 2 here, that says we can distribute this exponent inside the parentheses, and then also we can do this operation in reverse. Okay, so back to our problem. We'll start with the left side where we have 6x to the 3x. So what I'm going to do is I'm going to raise this, I'm going to square it. And the reason for doing that is then I can multiply this inside using our rule number 2 here, and we end up with 6x to the 6x, and that's going to be probably useful here in a second. So then let's just rewrite. We have our tower on the right, but so I've raised the left side, I squared the left side, so I need to square the right side. I'm gonna do, just to make it clear, I'm gonna do a quick substitution. I'm gonna call b equal to 2 squared. If I do that, we'll rewrite this again. And you actually, while I'm gonna do a equals 6x, just to kind of clean this up. So then we'll have a to the a, doing our substitution on the left. I'll leave 1, 2, we'll have 2 to the b squared. And so then our problem looks kind of a lot less intimidating right now with the substitution. So then we'll use our second rule and distribute this in here. And we'll end up with 2 to the 2b. But again, using that rule in reverse, I mentioned we can take either, just like the example previously, we can actually write this as, but look what we have here. We have 2 squared, and that's just b, so let's do another substitution, and we're just left with a to the a equals b to the b, which is exactly what we want, because then we're just equating base and exponent, and we can say that a equals b. Now let's remember what our a and b was we want to solve for x, not a. We have our substitution here. So we're just saying 6x equals 2 to the 2, but that's just 4. 2 to the 2 is 4. And we'll just divide each side by 6, and we end up with x equals 2/3 for our answer. And then what I'm going to do, I'm just going to go back and plug it in just to see if this really works. So if we have 6 times 2/3 to 3 times 2/3, that's going to be inside here, that's going to be 4. This is going to cancel with this. We're going to have with a 2 in the exponent, so that's going to be 16. But then 2 to the 2 to the 2 is 2 to the 4, which equals 16, so this works.